Lesson 31, Confidence Interval Estimation for one population mean. If we don't know the value of a particular population parameter, but we want to know the value, we can use confidence interval estimation to estimate it. Now, if the population parameter we're interested in comes from just one population, and it involves the mean, mu, then the following can be used as a guide to help us construct a confidence interval estimate for this one population mean mu. To begin, we must select 1 minus alpha, the confidence level. Unless there exists a compelling reason to do so otherwise, confidence interval estimates are constructed using the customary 95% confidence level, or 0.95 decimal. Now, after the random sample data has been entered into a list, or the sample statistics, x bar, s sub x, and n have been determined, the t-interval command on the TI-84 calculator will calculate the confidence interval estimate for one population mean mu. So to find the t-interval command on the TI-84 calculator, we press stat, because we're doing statistics, arrow over to the test menu. This is where all the confidence interval and hypothesis test commands are found. Arrow down till the cursor is next to t-interval. Press enter to select. Then you tell the calculator what we have to input. We either have data or statistics. When data is selected, we must enter into the calculator into a list the sample data. The frequency is 1 for the purposes of this lesson, and C- level, the confidence level, is our customary 0.95. But if we have statistics to input, we need to arrow the cursor over to stats, press enter to select, and then down arrow. We then enter in the statistics, the sample mean x bar, the sample standard deviation s sub x, and the sample size n. C- level is the confidence level, and then we arrow down to calculate. And with the cursor blinking on calculate, we press enter, and the calculator constructs our confidence interval. Under the t-interval command, in parentheses, you'll find two numbers separated by a comma. The first number is the lower limit L of the confidence interval, and the second number is the upper limit U of the confidence interval. So we can just read the results off the calculator screen to produce our confidence interval estimate. Now, this is the formula that is programmed into the TI-84 calculator's t-interval command. The sample mean, x bar, is the point estimate of the population mean, mu. T times the s sub x over square root of n is the margin of error. And adding and subtracting the margin of error to the point estimate produces the interval estimate. Subtracting produces the lower limit L, adding produces the upper limit U. This confidence interval estimate is constructed using the results of the central limit theorem. Therefore, in order for the normal approximation to be reasonable, either the sample size must be sufficiently large, or the distribution of the population from which the random sample was selected must reasonably follow a normal distribution. So if the distribution of the population from which the sample is selected is itself normally distributed, then using this formula, which is based off of the normal distribution, will produce estimates regardless of whether the sample size is large or small. But on the other hand, if the distribution of the population from which the random sample is selected is not normally distributed or is not known, then the result of the central limit theorem tells us that the distribution of the sample mean x bar becomes closer and closer normally distributed the larger the sample size is. So in general, in statistics, it's accepted that a sufficiently large sample is one that is an n greater than 30. This allows for reasonable approximations to the normal distribution based off of the central limit theorem. Now, the confidence interval estimate for one population mean mu is expressed symbolically as L less than mu less than U, where L and U are the calculated values of the confidence interval. And after we have expressed the confidence interval symbolically, we then need to express the answer verbally. So the confidence interval estimate for one population mean mu can be expressed verbally as indicated here, using the actual calculated values of L and U in terms of the issue under investigation. That is, in words of the problem. So we can say that the population mean mu is estimated to be between the lower limit L and the upper limit U with 1 minus alpha times 100% confidence. The upcoming examples help demonstrate how to construct a confidence interval estimate for one population mean.